So in grade 10, we did some triangle geometry, which is trigonometry, and we used the right triangle, and we use the following definitions. So if we have an angle theta here, we would consider this side opposite. Okay, so that's opposite to the angle, so we call that the opposite side. The adjacent side is the other leg of the right triangle, okay, which is right next to the angle, and the hypotenuse represents the longest side. And we defined the trig ratios, the primary trig ratios, as cosine as adjacent compared to the hypotenuse, the sine is opposite compared to the hypotenuse, and the tan is opposite over adjacent, which is essentially the slope ratio. So some people like to remember this with Sohcahtoa, and that's just an acronym just to help us connect the sides to the different trig ratios. What I would like you guys to start thinking about, though, is that the cosine goes with the horizontal, and the sine goes with the vertical, and tan is slope. And that's a good way to kind of remember and keep track of the sides, because that's a definition that we're going to use quite a bit. So when we look at the sine ratio, this sine ratio is another way to describe the angle 33 degrees. So there's essentially two ways to describe this shape of this triangle. We can describe it with the angle. Okay, so 33 degrees, when we say 33 degrees, the angle, we should have a picture in our mind what that triangle, 33-degree right triangle, is going to look like. The other way we can describe this is with the length of the sides. Okay, the ratio of the sides gives us an idea, again, of the shape of the triangle. So that's when we talk about the sine ratio gives us a shape. And to be able to go from the angular description to the ratio description, we need to be able to translate that. And sometimes we can translate that without a calculator, but very rarely. We often need to put it into our calculator. And the calculator is what translates between the angular description of shape and the ratio description of shape. So when I punch in sine 33 on my calculator, I get this ratio 0.5446, so I'm going to round that to 45. And that means that the opposite side to the hypotenuse side, so this is about 54% the length of the hypotenuse, and that ratio will give us about a 33-degree triangle. So in this case here, this is pretty close to that, so this is maybe a little bit bigger, and that angle there is pretty close to 33 degrees. Okay, so cosine of 58. So again, we should have in mind what a 58-degree triangle looks like. Okay, and we can then translate that into an adjacent hypotenuse ratio by using our cosine function on our calculator. Again, without that cosine function, it's hard to, well, it's very difficult. There is no like add subtract calculation that allows us to convert this degrees into the ratio, because there are two different ways to describe the same thing. So when I put this in my calculator, I get 0.5299, so I'm going to round that to 530. And when I talk about this ratio, yeah, that's about, the adjacent is about 50% of the hypotenuse. That's going to give me about 58 degrees, which is kind of similar to here, because these are fairly complementary to each other, right? They're just looking at from different perspectives. Tan of 45 degrees. So if I have a 45-degree triangle, I can draw the picture of that. And I really don't need my calculator for this, because this is one angle, and there's not very many like this, that I know the slope of that angle is just 1 to 1. So when I talk about the tan of that angle, I'm just going to say 1. If you want to check, you can put it into your calculator, and your calculator will give you the exact same thing. But there's some angles, like 45 degrees, because of the symmetry of it, we do know the ratio. We already know what the ratio of the sides are going to look like. And then tan of 88, okay, if I were to sketch 88 degrees, it's a really, really tall triangle. It's even taller than that. So I know that the slope ratio is going to be really big. So when I work out the slope ratio, okay, so I'm going to go tan 88, and I get 28.636. So this is equal to 28.636. And the rise over 1 ratio for that 88-degree triangle is going to be 28.636 rise to 1 run. And that tan is my slope ratio. So when I talk about tan, I really should be talking about slope. So this is converting angle, the angle description of shape. 58 degrees gives us an idea of shape. The ratio of 0.530 gives us a description of shape as well, but in two different ways. One is an angle. Cosine gives us the ratio. Okay? And we want to be able to make sure we know how to convert from angle to ratio, but also going the other way. It's important to undo the ratio. Once, if we have the ratio that's describing the shape, we should be able to go back to the angle. And we should make sure we keep track of when we are dealing with what. So here we started off with angle, okay, and we need to go in this direction. So to go in this direction, we need to use sine, cos, tan. But if I were to give a ratio, for example, slope of 1, and I need to know the angle, I would need to use the inverse function, the inverse sine, or arc sine, arc cos, arc tan, and go in this direction using my calculator to calculate angle. So sine, cos, tan uses an input of angle, okay, the angle which tells us shape, and then we just give another description of shape, the ratio description of that same angle, by using the sine, cos, tan. If I want to go from the ratio, if I know the shape of the triangle based on the ratio, I want the angle, I go in this direction, I use the inverse to get the angle. So make sure you understand when we use sine, when we start with angle, when we use arc sine, arc cos, arc tan, when we start with the ratio.